Hi, welcome to Sunil Maths tutorial, functional analysis class number 70. In this video, we solve a problem depends upon the previous theorem. Let us see the if P and Q are the projections on a closed linear subspaces M and N of H, then prove that PQ is a projection implies and implied by PQ is equals to QP. In this case, show that PQ is a projection on M intersection N. Okay, let us prove this statement. Let capital H be a Hilbert space and capital M comma N are closed linear subspaces of capital H, and P comma Q are projections. P comma Q are projections defined on M and N respectively. It means P is a projection on M, Q is a projection on capital N. So by the definition of projections, they satisfies two conditions: P square is equals to P and P star is equals to P, as well as Q square is equals to Q, Q star is equals to Q. Q square and Q star both are equivalent to Q. This means one is self-adjoint operator, the second one is idempotent operator. And remember that M is the range of P. Capital M is the range of P and N is the range of Q. This is important point to solve our problem. So right, our aim is to prove that we have to prove that the product PQ is a projection. The product PQ is a projection implies and implied by PQ is equals to QP. PQ is equals to QP. Right. Suppose PQ is a projection on H. PQ is a projection on capital H. So since PQ is a projection on capital H, then by the definition of projection, PQ whole star is equals to PQ. It is very simple. We know that here it can be written as Q star into P star is equals to PQ. Already we said that Q star is Q, P star is P, it is equals to PQ. Therefore, we conclude that PQ is equals to QP. PQ is equals to QP. Now you have to prove the converse part. Converse. Suppose PQ is equals to QP. We have to prove that PQ is a projection. PQ is a projection on capital H. Now PQ star is equals to, this is very simple, Q star into P star, which is equals to Q into P. Because Q star is equals to Q, already we said that Q star is equals to Q, P star is equals to P. Already we assume that QP is equals to PQ. Here, suppose PQ is equals to QP. It can be written as PQ. Therefore, PQ whole star is equals to PQ. This is nothing but PQ is self-adjoint operator. PQ is self-adjoint operator. Now we are going to prove the idempotent. PQ whole square is equals to, PQ whole square is equals to, you can write PQ into PQ. PQ into PQ. It can be written as, by using associative axiom, P into QP into Q. Again, we said that QP is equals to PQ. So it can be written as P into PQ into Q. So after removing the brackets, you get PPQQ. This is nothing but P square Q square. Again, we said in the introduction part, P square is equals to P, Q square is equals to Q. You simply write PQ. So we prove that PQ whole square is equals to PQ. This is nothing but this is nothing but idempotent operator. Already we proved that PQ star is equals to PQ. These two conditions shows as PQ is a projection. PQ is a projection on capital H. So right, finally we are to show that finally we are to show that we are here to show that PQ is a projection. PQ is a projection on M intersection N. This is our final aim. So here this is nothing but it is equivalent to prove that the range of PQ is M intersection N. That is, the range of PQ is equals to M intersection N. The range of PQ is M intersection N. Then obviously PQ is a projection on M intersection N. To prove this, let us take capital R of PQ denotes the range of PQ. Remember that capital R of PQ denotes the range of the projection PQ. Now take an element. Let us take an element x belongs to M intersection N. If x belongs to M intersection N, then x belongs to M and as well as x belongs to capital N. Now PQ of x is equals to P of QX. P of QX means you simply get Px because remember that Qx is equals to x. Why? Because this x belongs to capital N and N is range of Q. So obviously Qx is equals to x. So similarly Px also equivalent to x because with the same argument Px is equals to x because x belongs to capital M and M is the range of P. So we prove that PQ of x is equals to x. This condition shows us this x belongs to range of PQ. Therefore, we take that x in M intersection N. We prove that x lies in R of PQ. This condition shows us M intersection N is subset or equivalent to R of PQ. Let it be equation number 1. Now suppose we assume the conversely. We prove the converse part of equation 1. Suppose some y belongs to R of PQ. We take an element y belongs to R of PQ. By the definition, where R of PQ, what is R of PQ? R of PQ is nothing but range of PQ. By the definition of range of PQ, PQ into y is equals to y. PQ into y is equals to y. PQ into y is equals to y implies as PQ, by the definition of range, PQ of y is equals to y. It can be written as operating on both the sides with the projection P. P of PQY is equals to PY. P of PQY is equals to PY. Which implies as P square QY is equals to PY. P square QY is equals to PY. Which implies as again P square is equals to P. So PQY is equals to PY. PQY is equals to PY. But actually PQY is equals to Y. Here the first one. PQY is equals to Y. So here in the left side you replace Y by using this fact. PQY is equals to Y. So here PQY is there. So Y is equals to PY. Y is equals to PY. Y is equals to PY. PY is equals to Y it means this y belongs to range of p. This y belongs to range of p. What is range of p? M. So y belongs to M. Similarly, y belongs to n also. So this condition shows us y belongs to M intersection n. Therefore, actually we take that element y belongs to R of PQ, range of PQ, and we show that y belongs to M intersection n. Hence we conclude that R of PQ is subset or equivalent to M intersection n. Let it be equation number 2. From equations 1 and 2, we conclude that R of PQ is equals to M intersection n. It means the range of PQ is equals to M intersection n. This condition shows us PQ is a projection. On M intersection n. This completes the proof of our solution. So hence proved. So you observe that this is a problem depends upon the previous theorem. In the next video, we solve one more theoretical problem depends upon the same definitions of projections. Keep learning. Wish you all the best.